Good morning, ladies and gentlemen. This is Mr. Smith, and this is 1.22 transformations. So we're going to build on what we learned in 1.21, and this is still dealing with quadratic relations. At the start, we have transformations, and our first point is y equals x squared. And when we transform it, it becomes something that looks a little bit like this. This is our vertex form, if you guys remember what that is from last lesson. Y equals a bracket x minus h n bracket squared plus k. The only difference is that we have minus h instead of plus h. The reason for doing this is because it makes a little bit more sense when we're finding the vertex and when we're transforming the graph. So essentially it's the exact same formula that we had earlier, except instead of a plus we have a minus. And now we're going to see how these shifts affect the parabola. And the reason for doing this differently is so that we build on your understanding without introducing too much. So now we've changed it from a plus h to a minus h in the bracket. That should be enough of a new change for you guys to understand what's going on. The transformations, stretches and compressions are brought on by the a value. The reflections are also brought on by a. Translation shifts are h and k. And then I have a few instructions here. So I'm going to tab back and forth. Use Desmos to sketch the graph of y equals x squared in black. Look at it, admire it, and memorize some of its points. Use a slider to investigate how the changing the value of a x squared. And we'll notice that when a is reflected across the x-axis, a is less than 0. It'll be a vertical stretch is if a is greater than 1 or less than -1, and I'll demonstrate that as well. And vertical compression when a is between 0 and 1 or between -1 and 0. So I'm going to tab over and we'll take a look. Okay, so here's my Desmos app open. I just have it running on my computer. It has a little bit of a top cut off. I was able to resize it so it fits nicely. Here in red, we just have our standard y equals x squared. I would ignore the rest of the stuff for right this second, except for line 2, of course. Line 2 will be in blue. It's just laid over top of the red because a is equal to 1, so it's essentially the exact same as that. What I'm going to do is I'm going to reduce this down to -10. Or -1. Let's start with -1. When a is equal to -1, it's reflected perfectly. So when we have the point 0, 0, it's reflected across the x-axis, so we still have the point 0, 0. We also have the point 1, 1. That means that down below we'll have the point 1, -1, because it's reflected, right? So the y values will just be negative. So if we have 2, 4 up here, we should have 2, -4 over here. There it is. Perfect. And if I want to stretch this, I would decrease it, making it a greater negative value. So if I have -10, when I go to 1, it'll be -10. So if I zoom out, I should have 1, -10 as my first step. It's not perfect. So 1, -10. No matter what my a value is, that's what my first step will be. So if I had -6, the first step will be 1, -6, right there. So as we see, it's being stretched. It's like you're grabbing the top and grabbing the two sides and stretching it. And because it's negative, it's also reflected. However, if we want to do a compression, if I reduce it to -0.5, if I can get there, perfect. So now it'll be 1, 1/2. There it is, 1, -1/2. And then it'll be 2, -2, because the second step is 2, 4. So the y value will be cut in half, so it'll be 2, -4. or to -2. Perfect. And then I can do this on the positive quadrant. If I can get positive 0.5. So now we see 2, 4 will become 2, positive 2. And then if I increase it beyond 1, if it's 1, it's exactly the same. If it goes beyond 1, let's leave it at 3. So the first step will be 1, 3 instead of 1, 1. We have 1, 3 as our first step. Approximately there. And then if we had 2, 4, that would become 2, 12. Because 4 times 3 is 12, and 3 is our A value here. It's slightly off. All right, so that's a good demonstration of what the A value does. It can stretch it. It can compress it if it's between 0 and 1. So say we have 1/2. Come on. There it is. Say we have 1/2, so that's 2, 2. So that's a compression. It's being compressed vertically. Think of it being squished from the top and bottom, and it's being squished down. And a vertical stretch is when it's being pulled back like a bow. And then I can play this through, and it shows you that it just reflects. If A is equal to 0, we get a flat line that just travels along the x-axis, and it's no longer a quadratic relation, it's a line. All right, next step. The next step we're going to look at, because we've already checked the reflection, good. We checked a vertical stretch, yeah, we noticed those. We noticed a vertical compression, we noticed those. Now we're going to take a look at H and K. So we're going to create another graph. I've already have it created, so I'll just tab over and demonstrate that. H is a horizontal shift, right if H is less than 0, left if H is greater than 0. I'll have the Desmos graph included on Brightspace for you guys so that you can mess around with it at your own pace and double check and even use it as a tool, a learning tool to help you work through the notes just so you can see a visualization. So now we're going to shift horizontally using H. Remember, it's x minus H now, so it's going to be different than when we learned about the vertex form. Remember, the vertex is negative H, positive K. That's the point for your vertex. So we're going to notice our vertex shifting. In our last one, when we were using A and moving it around, it didn't affect our vertex, but H and K definitely do. So let's go and take a look at that. All right, now we're back here. I'm going to enable my my purple line here, which will be my adjustment for H and K. Let's try a horizontal shift because that's our first step. I'm going to increase H. And when I increase H, let's say 2, our vertex changed to 2, 0. Well, if I decrease H, there we go. So if H is negative 2, my vertex becomes negative 2, 0. Now remember, that's going to look like x plus 2 because it's minus H here. So x plus 2 squared plus K. And the way I remember how to find the vertex is whatever x value is going to make what's in the brackets equals 0 is where my vertex is going to be. So if this is x plus 2, the vertex is going to be at negative 2 for the x value. I'll say that again. Whatever makes this bracket equals 0 is the x value for your vertex. This is important because this is going to make a lot more sense when you look at the vertex form and at the transformation formula that we have here, which is also just a vertex form. And it makes that final connection. So whatever makes this bracket equals 0, x minus H, so if this is x minus minus 2, that's x plus 2, that means that negative 2 subbed in for x is going to be 0 in this bracket. You want to make whatever is in this bracket 0, whatever x value you need. So if H is positive 2, for example, or let's change the number, positive 3. If h is positive 3, that means this is x minus 3 in this bracket. The positive 3 value for x will be where our vertex is, which we see right here. And that doesn't matter for k value. You can move k up and down. It'll change where the y value is. However, your x value is not moving around, and that's how you find your x value for your vertex. And that helps me to understand the translations, and hopefully that helps you understand the translations and transformations of parabolas. So A will make it thinner or stretched or compressed, and h and k are going to move it, well, h is going to move left and right, and whatever your x value is to make the brackets equal 0 is where your vertex is going to be for the x value. Okay, let's take a look at k, because I did kind of gloss over that really quickly. I'm just going to leave h at 3. If k is 0, the y value for the vertex is going to be 0. If I increase it, it's going to increase the y value. So if it's 3, the y value will be now 3. If it's 2, the y value of the vertex is now 2. It just moves the entire parabola up and down. If the k value is negative 5, the y value of the vertex is now negative 5. So k is not at all as interesting as h is. H, basically, whatever makes the bracket equal 0 is gonna make your life a lot easier to remember it that way, as opposed to trying to memorize all these different formulas. That's what I use. It's up to you. If you want to stick with one of the two formulas, that's fine. I'm just trying to deepen your understanding of this. Okay, we're going to jump back over to the lesson now. Okay, now we're going to take a look at our first example. Describe the transformations from the graph y equals x squared to the graphs below, determining the relations. Well, we have an a value of 1/2. That means it's going to be compressed vertically. And that's important that you say compressed vertically, not horizontally. We're always dealing with vertically with parabolas. So it's compressed vertically by a factor of 1/2. And it's translated, remember what I said? It's going to go left or right. Well, this has to be positive 4 for the x. This is positive 4. Then we have x minus 4 squared, which just equals 0 squared. If I just take out that one section there. So x is going to be positive 4. That means it's going to shift right, like I drew the arrow. It's going to shift right 4 units, and then negative 7 here shows us that it's going to shift down 7 units. So let's reveal vertical compression by a factor of 1/2. It's a horizontal shift, right 4 units, and it's a vertical shift down 7 units. So we're going to do the same thing on the next example. Let's take a look at the a value. It's negative 3. So it's going to be reflected across the x-axis because a is less than 0, like we have up in our first indication up here. Then it's less than negative 1. That means it's going to be vertically stretched because it's smaller than negative 1 or greater than positive 1. So it's going to be vertically stretched by a factor of 3 and reflected across the x-axis. There's our first two things. Then we have x plus 3. Remember what I said? Take what's in the brackets. And whatever's going to give you 0 is where your vertex is going to be. If we have x plus 3, well, negative 3 plus 3 equals 0. That means that it's going to be shifting left this time because it's going from 0 to negative 3. So it's going to shift left 3 units. And then we have plus 1 for our k value, which means it's going to shift up 1 unit. There we go. And that is the first page of this. That should demonstrate very clearly how to analyze these. Example 2, write an equation resulting after y equals x squared undergoes the following transformations. So now we're doing the opposite. A vertical stretch of 2. So if it's a vertical stretch of 2, that means a equals 2. Reflection across the y-axis, that means a is going to be negative, and it's a vertical stretch of 2. So that no longer applies. It's going to be negative 2 now because it's reflected across the x-axis. And a vertical shift down 10. Well, that tells me that k is going to be negative 10 because, k equals negative 10 because it's going down 10 units. If it was a horizontal shift, then we'd have to deal with h. Okay, so my guess would be y equals negative 2 bracket x. Well, we don't have an h value, so it'd be minus 0 plus our k value, well, plus negative 10, which would just look like, if I simplify this, minus 10. Negative 2x squared minus 10. And let's reveal. Wonderful. Okay. Moving on to the next one. Vertical compression divided by 4, which is just a vertical compression of 1/4, right? Because 1/4 is 1 divided by 4. So that would tell me that that's going to be my a value. No reflection across the x-axis, so it is going to be a positive number in this case. A horizontal shift right 5 units, which tells me something's happening with h. If it's going right 5 units, that means x is going to be positive 5. Here's where things get a little bit confusing. It depends on the formula you use. I'm going to say h is positive 5 because it's going to shift right 5 units. And this is why I like using the new formula that we have, you know, where it's y equals ax minus h, not plus h squared plus k. Because if you use the minus h, it makes the horizontal shift a little bit easier to read and redistribute. So if I have h equals positive 5, when I sub it into this equation, it's going to be subtract 5. So it's a horizontal shift right 5. All right, now my vertical shift up 9. K is nice and easy. The trickiest part is getting the h value. If it's up 9, it's just plus 9. Now I have all of this. I'm going to rewrite it out. I have 1/4 here for my a value. X minus the k value, so minus positive 5 is just minus 5. Don't forget the squared. And then plus 9 at the end. That's what I'm guessing, and let's reveal. Perfect. Okay, moving on to the next example. Sketching graphs using transformations. Start with a table of values for y equals x squared. Next, you're going to stretch and reflect the x values times a. So you're going to multiply all of your y values by a, then shift the y values plus or minus the k value. So multiply by a, then shift using k. But we forgot one more variable. We forgot our h variable, and then you shift the x values using the plus minus h. Okay, let's use transformations to complete these table of values. The way I would do this is usually, I would just follow this actually, multiply by a. So multiply 9 by 4, then subtract 8. 9 times 4 is 36. Subtract 8 should be 28 for our first y value. Good. Again, let's do this with 4 just to illustrate what's going on. So 4 times 4 is 16. Subtract 8 is just 8. 1 times 4 is 4. Minus 8 is minus 4. And that's how I'm getting my y values, is I'm multiplying by 4. I'm multiplying by 4, then subtracting 8. Next, I'm going to shift my x values according to the h. This 0 is how I usually start this, is where my vertex is. This is now going to become 5 because it has to be positive 5 for this to be my vertex. I need to make this equal 0. So that means I'm adding 5 to everything. So I add 5 to this. This should become 6. This should become 4. This should become 3. This should become 2. Because all I did was I added 5 to all my x values. And the way I know how to do this is I make my vertex equal 0, and whenever we're looking at y equals x squared, 0, 0 is always our origin is always the vertex. That means that to go from 0, I need to go to positive 5, which means I just need to add 5 to all my x values then. Okay, next example. Here we have a new graph where you need to sketch the transformations given this graph here and examining our transformation of table of values. This is just y equals x on the left. On the right, we need to transition everything. So in order to get to 0 in our brackets here, x is going to have to equal 3. So from 0 to positive 3, right? Because I have x minus 3 in brackets, I need that to equal 0 in the brackets, which tells me positive 3 minus 3 equals 0. Therefore, I'm adding 3 to my x values. So to reveal my x values now, bam. Negative 2 plus 3 gives me 1. Negative 1 plus 3 gives me 2. 0 plus 3 gives me 3, so on and so forth. And that's pretty straightforward. Now let's work on the y values. I need to multiply everything by negative 2 and then add 5. So y values are negative 2 times y plus 5. Make sure that negative's clear. Okay, 4 times negative 2 is negative 8, plus 5 should be negative 3. That should be our first one. Good. 1 times negative 2 is negative 2, plus 5. That should give us positive 3. Good. 0 times negative 2 is 0 plus 5. That should be positive 5. Good. And so on and so forth. Notice how it reflects across the vertex, that or our axis of symmetry. And there's our steps right there, revealed. Okay, now I'm going to graph this using the transformations. I know it's positive 3 is where my vertex is going to be, so I put a little line there to help me find my axis of symmetry easier. And the k value is positive 5, so that's my maximum. I know this because the a value is negative. That means it's going to open down. So now I can use my step pattern. And it's 2. My step pattern will be 2, 6, 10, right? Because we go from 1, 3, 5. Then multiply it by 2 as you work your way to the original, or to the next step. So over 1 down 2, over 1 down 2, and we can verify 2, 3, so that's 2, 3, and 4, 3, that's 4, 3, and then our next one should be 1, negative 3, because it's over 1 down 6. Over 1 down 6. There is our gorgeous parabola driven or drawn by a expert artist who's really good at drawing on tablets. Okay. You guys can work on assignment 1.22. Take your time to work through it. You can always use that Desmos tool. I will have that provided for you as well. Just make sure that you understand how to do this without using it. Redo the questions that you needed to use it for. That way you know that you've got it completely memorized. You don't need extra help or extra tools to do the work. Okay. Good luck, and I'll hear from you soon.